there is a loss of confidentiality. So in this case, the data have both transit and the data is moving. So both the cases to achieve the confidentiality. So you are doing encryption. So also you'll be implementing some access control kind of things like so you'll be implementing a kind of a proper your server is there. So where you have your server have a proper credentials to access there, where you must be authenticated. So that is also the confidentiality. So in this case, when the data is transferring, so make sure you will be doing a encryption of data, and when the receiver receives, it will be decryption. So what is the encryption? Converting plain text to a ciphertext, which is not readable and which is not understandable by any other people. Okay, let's say, as I said, A to B I'm sending, right? So in this case, so what I'm doing, so for example, I said I'm sending hello. So in such a cases, right? So in such a cases, what happens? This plain text hello information has been converted into some what we call as a some fixed character, something alphanumeric, ciphertext format. Maybe assume it will be like say H K N L kind of thing. So this is what which nobody can, even though if there is a middleman can see, he cannot understandable. So only the receiver and sender knows what is this. So when the when the receiver receives, he can able to decrypt this information. So this is a simple, this is what we call as a simple encryption. So here not we are not doing anything else. We're just converting it to a plain text to a simple text. So here I'm using a something called is a A is the algorithm to do this activity. Hello will be converted into or will be encrypted into some hype some some ciphertext format, that is HKNL. Example I'm telling. So here you are using a some A is the A is the encryption algorithm to do this activity in between A and B. So again, when B receives the data, so the same hash value, sorry, the same encryption algorithm is responsible to decrypt the data. So just think about, so this is the A algorithm. This is how it converts the data when this data goes, right? This is the A and B communication. Let's say C and D communicating, right? So, and now hello is the I'm sending between C to D. Now, if I'm using the same algorithm, right? So this algorithm, A algorithm generates the same HK and L, right? So now you understand, right? What you understand. So when the hello is passes through A algorithm, it generates this HK and L. So this is the standard. Okay. So and B receives it and it can able to decrypt it. But where is the confidentiality? So if D also knows that HKNL is the data. Okay, let's say this person already knows what, if you use the algorithm A for a hello data, what is the information you will get it. So that is HKNL, you know this, the D knows. So now A and B communication also known by the D also, correct? Because he's sending a hello and this guy D is a bad guy and he is intercepting the traffic, or he is capturing the traffic between A and B, correct? So now this is the case, HKNL was the understandable by D, because this algorithm, if I give the input as hello, what it generates, it can be understandable by this D. Now, so we just did a simple encryption, right? So this is the drawback, even though you convert into a ciphertext format. But what is problem is here by doing a simple encryption. So where there is a loss of confidentiality in some cases when the intruder or when the attacker knows. So if I give a some input, what sort of output it is going to generate, so that he can able to know. So in such a cases, it won't work, right? The confidentiality of the data will not work even though you did an encryption. So what is the solution for this? What is the solution? The solution is adding a keys. Okay, so let's have the discussion of keys. Okay, so basically, so uh we have the keys like a two keys, what we call as a public key and private key. Okay, so this is a public key and private key. Just give me a second. So what is a public key and private key? Let's discuss this. So basically the encryption, all right, so we have the two types of encryption. One is symmetric encryption. So many of you heard about this symmetric encryption. Okay, symmetric encryption. So we have asymmetric encryption. So we all know the theory, right? So basically symmetric key uses public key of both the sides when you're transmitting a data from sender to receiver. So it uses any of these key. Okay, either public key or private key, right? Right. What I can say here is, here I am sending a data, right? So from here to here. Now, so what I'm going to do is, so when I'm sending a data from sender to a receiver, let's say, so in this case, so what happens is, let's take another example. Let's say I have A, B, C, D, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, Z. I hope everything is correct. Okay.
Very much good.
Sorry. Okay. So what you can see here is, let's say just imagine. So now the symmetric encryption, how the symmetric encryption will be there. So basically the keys are just a zeros and ones, where you will be adding this zeros and ones information. This is actual information. This is actually we used to call in mathematically. So so many of you gone through the cryptography of in your college days, right? So if you are a BTech student and if you are a CSE background, probably you'll gone through the cryptography on your final semesters or third year. So where you have discussed, I mean, where you have the different sessions on the algorithms, especially the symmetric, asymmetric, different algorithms. So I think if the people have the fair understanding, probably you can quickly understand here what I'm discussing. So now what I'm going to say, so here I am sending a data call. Okay, so what I'm sending is, I'm sending a data, what the hello. Okay, so this is the data plus what I'm adding here is a key. So any key, either public key or private key. Okay, so that so now, and this key value, this encryption key value, let's say this encryption key value is, what is this encryption key value? Let's say this is the example 5. Okay, so the hello data, so this particular hello data is going through the encryption. Okay, so this info, this hello is going to this encryption. After that, the key will be added. Okay, so now this particular hello will be, after adding the key, so the value of 5 means the encryption key value is equal to, I said 5 means, so what it is going to do, the H, right? So let's take, so I said H, okay. This H will be forwarding, the H will be forwarding to 5 steps. So let's say here, what is the 5 steps? This is the 1, this is the 2, this is the 3, this is the 4, and this is the 5. Okay. So now what is the value after jumping into 5? The value is, the resulting value will be, what is the resulting value? M, correct? After 5 jumpings means, so I said here the encryption key is a 5 means it is jumping a 5 letters. So now the value is M. If it is a I, N. If it is a J, O. Sorry, I'm sorry. So sorry. So H stands H. If I jump into a 5, it will be M. Now what is the next letter? E. So where is the E is coming here? So after a 5 gems, so right, this is the first gem, second, third, fourth, fifth. So this is the J. So after a 5 gems of E, then it is the J. Okay. Now L. So L. So after here is a L. 1. Here is a L, right? So this is the first gem, second gem, third gem, fourth gem, and fifth. What is the fifth after L? After 5 shifts or 5 jumps, it will be Q. Again L, again Q. So O. So O after the 5 jumps, there will be P. So P, Q, R, S, T. So T is the final value. Got it? So this is the, now after adding key, okay, so this is the output. Okay, this is the output after adding a key. So hello after converting into a symmetric, ciphertext with an encrypted key, okay, either public key or private key, then the value is this. Okay, so now if this data M Q J, M J Q Q T has been transmitted, so this is the encrypted data. Got it? Now, so how the decryption happens here? So you are using the same key value. So encryption is a private key, so that is also 5. So you will be using the same key again to decrypt. How it will be happen now? So in this case, you will be, reverse process will happen. So M will be reversed, right? So now if you go here, so first, what is the M here? So M is here. So the inverse is happen here. Inverse method we will be happening. While decrypting the data, the inverse method will happen. So from M to, so 5 steps for backward. This is the backward. So what is the 5 steps backward from M to L, K, J, I, H. So you got a H, right? So first stage, what we did, we forwarded, we move forwarded, correct? So the while the receiver receives the data, he will backward. So so now what is the data here? MJQQT. So when you go back the MG 5 steps, so you will get, what is the value you'll get? M2, first you go to the L, it is going backward, and then you'll be going to the K, J, I and H. You got a H. And from the J, you go back to the 5 steps, you will get a L, E. And if you go back a 5 steps back, then it will be a L and L. So finally, you'll get the your original data after decrypting. So here, so what is happening here in simple, if I explained you in simple, the symmetric encryption. So where a symmetric encryption, what is happening? So you send a hello uh, to a encryption algorithm, and the encryption algorithm, and which is you added a key. You added a key value is equal to 5. Now the data was, what is the data you got here? MJQQT. MJQQT. So this is the, what is this? This is the forward. So now what happens? This is the reverse now. So I mean at the receiving end. So at the decryption, what you're going to do, you'll be using the same key, right? The key is same, either public or private, and so the value is this. Now this will go MJQQT will be inversed, will be inversed, so that what is happening here, you will be getting a your original message back. So the first stage, the sender will send a message and it will go to the encryption with a one of the key will be added. After that, the resulted output will be this, and this will be transmitted, and the receiver receives. Okay, from sender, the receiver receives the data. Okay, and now this is the receiver receives the data. He used the same key, the value is same, but now the inverse method he follows. The inverse method means going back, right? So going back, okay, and then he will convert. So M 5 steps go back is H, J 5 steps go back E. So this is how the symmetric encryption works. Got it? So any questions here? Okay. So this is the symmetric encryption. So now you can see here, there was a, probably there was some issues on the security side. Okay. So if the person knows, the attacker knows, what type of key you're using and the resulted output. So now you knows this, and attacker knows this information, and he also knows the private, or he also knows this key, right? So for example, he knows this is the key 5, and he also intercepts this data. The possibility was he can able to decrypt, but it's not that easy. But chances are there to decrypt, because if he knows the keys, okay, because you'll be using the same key for a both encryption and decryption. So that's where there is a possibility that if he knows the key, because you're using the sender side and the receiver side, probably he can, while decrypting, he can decrypt uh, by using the keys, but it's not that simple to. But yeah, so symmetric encryption will have certain chances, some chances to somebody can able to decrypt with a greater experience, with a greater knowledge, but not that difficult. But I mean, it's not that strong. It is not providing that great security in terms of the encryption. So so another one what we have is asymmetric encryption. So right, asymmetric, what is the asymmetric encryption we discussed? So what is the asymmetric encryption? So basically you will be using the two different keys here, two different keys. So transmitting, while transmitting, so you will be using either public key or a private key, public or a private key. So while receiving, it uses, so let's say, imagine if it is a public key while transmitting. At the receiving, the receiver should have the private key to decrypt it. So now how it works? If I use the symmetric encryption, we discussed how the symmetric encryption works. We discussed that you'll be using a key. That key will be like a 5 times will be jumping here, and then finally you'll be getting it. So the key is different, same here also. The receiver also key is same. So that is why you will be inversing the data, so that you will be getting this original data back. But how you will get back your original data using your different keys? How? So that is we are going to see here. So in this case, the same case, all right, let's go ahead and, okay, so no, just quickly, right? So here in this case, let's say this is the guy who is transmitting a data, and this is the communication channel, and so we have the person, okay, and so here the symmetric encryption, so where what he is sending the same example hello. Okay, so now here also, so here is the guy, he is sending, this is that data was transmitting. Now, so we have, what is this? So we have this alphabets A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So now what is the encryption key in this case? My case, let's say the same I'm going to take. Let's say it is a 5 is an encryption key. So in such cases, so it is going through an encryption. Okay, this data is going on a encryption algorithm. Okay, and the key value is what? 5. So now what is an output? What is an output after it is going to an encryption? So the encryption value, as you already saw, MJ QQP, correct? MJQQP. Okay, so this is the data are transmitting. Okay, and this is how it went. Okay, so now what happens, this MJQQT is a after an encryption with a encryption key of 5. So now what happens here is, when the receiver receives this data, the receiver receives this MJQQ data. So he will be performing the decryption. Now, so what happens here? This guy has to decrypt with some other key, not with a key 5, right? So he has some other key. So in this case, to get back this MGQQ data, so the symmetric will not go or will not follow the inverse method. So in such a case, so forward it will forward, let's say. So you sent, what is the data you sent here? What is the data you sent? M. So now where is the M? Here. Okay. So now here, what is the key you'll be using, right? So you'll be using the key is 21. Why? So the difference between H and M is 1, 2, 3, 4, 5 letters. So what is our total alphabets? We have 26. So 26 minus 5 is 21. So now you are moving forward 21 steps. So you're not going back, or like an encryption, what you do, so you will going back by because it is having the same key. both the sides. So now this is a different key. The key value is here is 21. So now you are stepping forward 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, X, Y, Z. Okay, 13, right? This is Y. Okay, so 1, 2, 3. Okay, let me. So after an M, 1, 2, 3. After M, N. This is okay. N is a 1. O, P. That is 3. This is 4. This is 5. And this is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So you have to start from here. So you'll be reaching to the, you'll be finally reaching to where? Hello, sorry, H letter. So just count it from here. 1, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So if you count it at 21 times, so you'll be reaching to hello. So just if you have the paper also, you can do it. Okay, so this is how. Now E. So E case, what happens? You will be, where is a E here? Here. So you will be going forward only, not a backward. So from E to, sorry, now the next letter is after M, what is the next letter? J. So if you move forward from J to 21 steps, so
So
J,
I'm sorry to cut you up. I'm sorry to cut you. After A, you have B, C, you have double C. How does that
oh yeah,
count?
yeah, correct. So that is where we are not reaching to H. So yeah. So if you have the book, so probably you can calculate, so let's say uh, from H, so you can calculate a 21, sorry, not H. So that is M. From M to, if you calculate a 21 times, where you will be reaching to H, correct? Is that make sense? Does that make sense?
Will the receiver have MJQQT?
Mhm. When the receiver have MJQQT, uh, it is reaching to after 21 steps forward. So where he is reaching, I mean, where the final data is getting. So if you have the paper and pen, so
No, it is, will the receiver will have that MJQQT
mm,
encryption code? Because we started the counting from M, right?
no, not from M. So we are starting from N. We were not considering M. So we start from N, right? So that
Yeah,
is why I mentioned one.
because
So
because
let's talk about 21. Let's just say if I say like this. So what is the after a M? So now we have, so N 21 times we will move N O M N O P Q R S T U V W X Y Z A. We were going for A B C D E F G H. Count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. You got it?
no, sir,
Yes.
my document, the encryption code of hello is MJQQT, right?
Hmm.
So if the receiver has this MJQQT code so that he can decrypt the information.
Absolutely. See, when you are transmitting hello, so that is an encryption key of what? 5. So that is 5 times forward. So in such a case, I use a private key, or if I say public key. So I am not using the same key again for a recipient side. So when I receives that, so when I'm sending a first the data, what I'm doing, I'm using a key, the value that is either private key or public key. The key value is 5. Got it? So
Okay.
after five
Key value.
times, after 5 times moving forward, after 5 times the data was rotated. All right, that is hello value is rotated of 5 times. M, J, Q, Q, T was formed.
Yes.
So now that data will be transmitted to a recipient, correct? So when the receiver receives, he's not using the same key here because for the security reasons. So he wants the more security. So maybe receiver when somebody is captured in between. Okay, so if you use the symmetric encryption, so he knows the key value if because you already use the public key while sending the data. So the receiver also using the same key while decrypting also. So the attacker in between can use the technology or can use his tool capabilities. So because he knows the same key, whatever the while sending the data is used, the same key is used and he can decrypt. He can able to decrypt it, but asymmetric encryption is used as the two different keys. One key is always public, another key is only know by either any one of these parties, like a sender or the recipient only knows the next key, right? So as simple as if you have the banking, or if you have some cases, some people maybe you are aware or not. So to lock the doors, so they'll be using one key, right? If you use the same key to unlock, so that is what we call asymmetric. All right. If you are while locking your door, you'll be using one key, and while you're unlocking it, you'll be using a different method to unlock the door. Instead, you will be using a biometric. So to unlock the door, it is not a key. So where you're not, it's a different method at all we are using. That is a what we call it's a completely a different way of unlocking the door. So here also you will be using a one key to encrypt the data. At the recipient side, it is using some other key that is a private key, so that nobody knows. Only the guy who receives the recipient only knows that. So that is a secret, So as I said, right, the door, right? So the door you will be locking with a key, so that if somebody have that key, with that key, he can able to lock it. If somebody have that key, so he can also able to lock it. But the same time, the recipient, so even though I'm an unknown guy, so with that key I can able to lock that house door. But while I wanted to unlock the data or unlock that door, what I need a biometric for sure. So locking with the key is simple, that everybody in my house or anybody outsider also can lock it. My door will be locked, but my door opening, right? So nobody should not enter into my house, right? So for that, what I will do, I will implement the biometric. So biometric means what? With my thumbprint only, my door will open. So anybody is try to put the fingerprint or biometric, so it will not open, right? So closing everybody do, locking of the door everybody do, but who can my door will open, my house door will be opened by only with my thumbprint. You understand here the concept? So the same concept here is also the same asymmetric encryption. So while sending the data, right? You'll be using a public key. So probably everybody knows that. But while receiving, when you are and decrypting the data, nobody knows what type of key you are using. So that is way the securely you will be decrypting it. So I hope I'm making the sense. Anthony, I hope. Maybe I thanks for that, recognizing the C was added a duplicate. So are you able to follow me?
Yeah, I am. Thank you.
Yeah. Yeah, thanks for that as well, to identify the C twice. Okay. So this is a simple example what I was saying, right? The door concept, the same concept is applicable here as well, because so decrypting is very important, right? Like opening the door. Okay, so now, right, M, if I switch M forward, it is forwarding only, not inversing. While the decrypting, so it is forwarding 21 times and you will be getting a H, correct? So now, what is the J? So J is E, right? If I forward J 21 times, okay, what it will be? K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, A, B, C, D, E. Correct? So count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. You got a E. J stands for, I mean, when you, while encrypting 5 times forwarded, that is a J, you got the J. At the same time, recipient, you forwarded 21 times to reach the E. So just do the same for if you have the paper with you or after the class also, you try this. You know, if you move 21 times, sorry, if you move 21 times the Q, you will get L. Okay, so this is the symmetric and asymmetric encryption. So you use symmetric encryption, what you will be using a same key while transmitting the data and while receiving the data. And at the asymmetric, we can see it will be it is not an inverse. You will be using a entirely a different key, right? And it is completely forwarded direction, not an inverse direction. This course is also available in uh, Udemy, and you can see here uh, the very first one, uh, which is the which is having which is the name of the course is Cybersecurity SOC and SIM for beginners to advance, and you can see clearly here the cyber talents, right? So you can have the this particular course have 26 hours of duration, which covers fundamentals of security operation to intermediate level of security operation concepts, right? So we started here with an intro of instructor and the course content, and then we started giving intro of cybersecurity, what is or cybersecurity, and what is all about cybersecurity, and major threats for organizations, and then what about the SOC, what the SOC team is doing in the cybersecurity space, what is an importance of security operations, and what is their responsibilities, and the different the models the SOC operates, and the different entry level opportunity, entry level trainings, and the certifications on security operations for who wanted to start their career as a SOC analyst, and what is the the career opportunities, the job demand across the globe. What is the future of this security operations center? And so that's the pretty much overview of the cybersecurity SOC. Which almost an hour of content which covers everything about security operations. Um, then what is essential for the security operation? A SOC engineer. So we start with the networking concepts where which gives you an overview of you know how the network operates. I mean, how the communication happens, and what are the different security controllers, different protocols, and the different ports and their port numbers, the different security controllers like firewalls, IPS, IDS, the proxy, endpoint security. So we'll be covering all these things, followed by some of the important components like DHCP, DNS, and other services like a SMTP. And then what is essential in terms of security analyst, the SOC analyst, the primary responsibility is to do a analysis. All right. So here, the security engineer or the SOC engineer, what he's going to analyze from these network security components or from the DHCP or DNS. So what is essential for them? It's logs, right? So we are going to see what all the different log fields we can see from these security controllers, and which is helping for security or SOC analysts to perform a different type of analysis in their day-to-day activities. And then we jumping into the terms which are regularly used in SOC operations, which is the fundamental terminology of in security operations, like what is a threat, what is a vulnerability, what is a breach, and what is an exploit. So it's we need to aware of these fundamentals, this particular terminologies, because if you're if you're starting your career as a security analyst, you should understand the different terminologies, what is their function, because every day you're dealing with this particular the terminologies. Make sure you should understand, you should familiar with this, the concepts or the terminologies. So we're going through, I think, more than we have 30 to 40 of security terminologies, which is essential for the SOC and which is used on a daily basis by the security operations. And then we'll be jumping into the one of the important concept, that is cyber defense concepts, where we start with the CIA, that is confidentiality, integrity, availability, and then we will be going to the cryptography, where we will be talking about encryptions, decryptions, different models like symmetric, asymmetric encryptions. How does it works? The different algorithms used in asymmetric encryptions, and you know also the CIA, what is confidentiality, integrity, availability, what is their importance in information security, why it is essential in information security, and also the cyber kill chain, which is the defensive security framework. How to how to deal with any sort of cyber attacks. All these things will be explained. Also the MITRE framework, which have different phases, which explains the entire life cycle of an attack. And then yeah, one of the phases on the MITRE framework or in the cyber kill chain, that's a reconnaissance, where the attacker initially targets one of the the banking sector or any other sectors, the target they fix. So in such cases they do sort of the scanning activities, where we try to fetch as much as possible information for the organization. In such cases, you'll be doing one of the method is port scanning. So where we try to get open ports, closed ports, where we'll be performing in this particular session, we'll be performing port scanning, how how to check the open ports for any sort of a server, and we'll be discussing about the IR, how to defend any sort of an attacks happen in your organization. So what are the different standard IR phases are there in order to in order to minimize the attack, or in order to quickly respond to the attack. So what is an importance of IR? And then the different ports and their functions, like we have a number of ports like DHCP, DNS, SMTP. So I have different number of ports where we have listed all the ports and explained different ports and their functionalities as well. And then the cyber attacks. So we will be talking about the different cyber attacks, like a DDoS attack, and then we'll be talking about MITRE, a man in the middle attack, spoofing attacks we will be discussing. So on the lecture 24 and 25, we'll be talking about ports, followed by cyber attacks and cyber attacks. So we'll be talking in these phases, in these lectures, we'll be talking about all this cyber attacks and ports and functions. Then we'll be going to the web applications. What are the top web application vulnerabilities? And so we have OSP. We'll be quickly introduce what is OSP, and then we will be jumping into the threat intelligence. So what is an importance of threat intelligence? How how threat intelligence is helping to the security analyst to proactively defend any sort of cyber attacks. So what is actually the cyber? Everybody thinks that the cyber threat intelligence only, sort of IPs, or IOCs like IPs, URLs, hash values, or something like that. But if you go in deep, so it's actually it's a wider, it's a big concept in terms of how how the attack method, how the attacker comes into the organization, and how he can successfully compromise the network. So what are the different techniques attacker used in order to achieve his target in an organizations, like how he achieved the privilege escalations, how he can perform the lateral movements. It's all the tactics, techniques, the procedure done by the attacker. So this cyber threat intelligence will have all this information, along with like like and like IP address, hash values, and uh, the domains, all these things. But majorly you should understand how the tactical behavior of or what is the different TTPs, the tactic, technique, and process used by the attacker. So it's the if you understand this, you can minimize, or you can stop the attacks, uh, because IPs like IOCs, like IPs, hash values, domains, which may not be which can keep on changes, so which may not be effective to secure from a proactive security method. But yeah, so it's understanding of the tactics, techniques, and procedure. So where we'll be discussing all these things in the cyber threat intelligence, what is the importance of it, benefits, all these things. Then we are setting up the malware analysis, and first we understand what is the malware, types of malwares, and then setting up the lab. Then we jumping into the one of the core component of security operations, that is the SIM, security information and event management. What is a SIM? And where we will be talking about different vendors in a SIM, like Logarithm, Splunk, etc. So then we'll be jumping into the Elasticsearch. We'll be talking about the architecture, the components, and then we walk through the UI, how the UI will be, and then and how we can create a rules in Elasticsearch, and then we will be doing some integrations, Windows log integrations to Elastic, and then we jumping into the Splunk, and we'll be going through the Splunk architecture and the different components in Splunk architecture, and then we set up the home lab. So the Splunk enterprise version of home lab, how to set up that, how to do the the free version of Splunk in our own system, in our own computer, and then how to perform the log. We took some sample logs, and then we ingest those. We upload those logs into the Splunk enterprise. Those logs are like the kind of security related logs, and then we do a log search, and then we perform certain commands execution. We are going through like some of the commands, and we try to fetch the information through Splunk, and then yeah, so finally we go through the ArcSight, which were the different components in ArcSight. So that's how we will be finishing up. We'll be wrapping up the course, and which is covering entirely for the security operations what is SOC is required. So we'll be covering everything. If you're interested in this course, so I'll be sharing the course link in the description itself. Um, so you can directly click the link, and it will be directed to the Udemy and my course. Thank you so much.